everyone, and hello Todd. Welcome to the latest interview in the Spotlight on series. Today we are going to be talking about polygenic embryo screening, which is going to be really, really interesting because it's a topic that I'm kind of unfamiliar with, but I know that there's loads of social and ethical issues that we can delve into. So before we begin, Todd, if you can just introduce yourself and tell everyone a little bit about what you do as well.
Yes, hi. Thanks for having me. It's a pleasure to be here. My name is Todd Lencz, and I'm a geneticist working at Northwell Health at the Feinstein Institutes for Medical Research and the Zucker School of Medicine at Hofstra Northwell. And I study a variety of different genetic topics, but in the context of this study, we are very interested in learning more about how polygenic risk scores are something that might be used in the context of in vitro fertilization and screening of embryos. And I can explain all of the terms that I threw into that sentence as we go along.
Yeah, I think it would be kind of good to just start off with kind of just embryo screening in general. And I know it differs worldwide, but what is the kind of current landscape of embryo screening? What is currently offered to people, and when is certain things offered to certain kind of couples and things like that?
Sure. So in the process of in vitro fertilization, a number of embryos are created for potential implantation. Depending on the health and age of the parents, there may be varying numbers of embryos available, and generally more than one are available, and different forms of genetic screening might be employed to determine which one to implant. And there are two main forms of genetic screening that are currently utilized, and these are monogenic disease screening. So if one or both of the parents are known to carry specific genetic variations that might cause a genetic rare disease, then these can be screened for, and embryos that are carrying that particular variant can be removed from consideration for potential implantation. So that's a fairly straightforward process. At the time that it was developed 30 years ago, it was not considered straightforward. It was considered potentially eugenics or playing God, but that is something that is relatively straightforward. Another form of screening that is sometimes employed is looking at whether there are any large-scale chromosomal abnormalities within the embryo. That's a little bit controversial because the accuracy of those methods is not currently well established. But the process that I'm studying now is a brand new concept that has only been recently introduced into the clinic. And that's the idea of using polygenic risk scores. These are very different than looking for an individual gene that is potentially related to a genetic condition like Tay-Sachs or cystic fibrosis. Those are monogenic diseases caused by a single gene that is well known, well identified, and relatively easily screened for. By contrast, most common diseases, things like mental illnesses like schizophrenia, or common conditions like type 2 diabetes, or breast cancer, or prostate cancer, these are caused by many, many genes throughout the human genome. And the risk for these is very complicated, but more recently, these polygenic risk scores have been developed, which sort of add up or sum up all of these small, tiny, tiny influences across many, many genes throughout the genome. And the idea of using these probabilistic risk scores, which add up all of these tiny genetic variations to give you a probability of whether one embryo might be more or less likely to develop a common disease like schizophrenia or type 2 diabetes. That's what we're currently interested in investigating.
So you mentioned kind of polygenic risk score. How is that currently being applied? Because I see that research papers all the time going on about how they're using polygenic risk scores, but how is it currently being applied?
Well, they're very new, and so the application in the clinic is quite experimental at this point. There's no clear protocol for how they should be applied. And what we're still trying to even really understand is how much of the risk are they able to capture, and how accurate are they in predicting the future, if you will. And the fact is that right now they're still only capturing about 5 to 10% of all of the variation that we can possibly explain in the future risk of the disease. So there's still 90 to 95% of the variance that's unexplained. So these are really still capturing just the tip of the iceberg. And the way that they've been investigated so far in adult patients is to consider adult patients for possible future screening. So there are studies ongoing that look very promising, for example, in various forms of cancer like prostate and breast cancer. And if you have a high polygenic risk score, maybe you should have more mammograms or a different type of prostate cancer screening protocol or more frequent checkups, this kind of thing, rather than saying you are going to definitely develop cancer, which is out of the question and never will be the case with these types of risk scores. Even in the future, they will never, that's the nature of the genetic contribution to these diseases. They're so complex, and so much of them is not determined by genetics, that it's never going to be that the polygenic risk score will be able to pick somebody out or pick one embryo out of a dish. Let's say there are 5 or 7 in an IVF cycle. They'll never be able to pick out with 100% or even anywhere close to that level of accuracy. So there are a few companies that are right now offering these services to detect relative risk of one embryo versus another in an IVF setting. So if a potential family has 5 or 8 or some number of embryos available in the IVF setting and one could be implanted, the idea is to take a single cell out of the embryo, screen it for all of these minor, tiny genetic variations, add up these scores, and determine which one has a higher risk for disease X, Y, or Z. And while that's currently being offered in the clinic by a couple of companies, in general, this is still something that is very poorly understood of how accurate this might be. And like I say, even in the situation of the adult clinic, there's no standardized protocol or standard of care where this is very well understood or widely accepted.
So essentially, kind of polygenic embryo screening is applying polygenic risk scores to embryos like during IVF. What is the kind of value of this technique now, and how has it kind of been made possible with the advanced technologies?
Well, that's exactly what my research is all about. We're trying to understand exactly what are the statistical properties of polygenic risk scores and how accurate it is currently and how accurate it might be in a hypothetical future if we had more knowledge of the genome and more refined and accurate polygenic risk scores. So right now, we have studied 2 different situations. First, we have studied polygenic embryo screening in the context of what we call quantitative traits like height or intelligence, things that can be measured on a scale of higher to lower. And what we find is that these scores are very inaccurate and not highly useful. We published that paper 2 years ago. And what we showed is that, for example, if you had a batch of 5 or 10 embryos, however many you were choosing from, you could run a polygenic risk score, let's say for height. And on average, you could identify an embryo that might be a couple of centimeters taller on average than one that might have just been selected at random. But the amount of variability around that for any individual couple, so I could tell you on average, yes, we can select an embryo that's going to be 2 centimeters, 2.5 centimeters taller than than if we hadn't selected just at random. But that's plus or minus 8 centimeters. In other words, there's a 25% chance that the one that we select and say is likely to be taller actually will be shorter than the average child. And we actually were able to test for this in a unique cohort of families that were very large families that had 10 or more children. And these were all grown children now in adulthood. And we were able to imagine, if these 10 children who are now grown adults, and we know their height, and we can look at their polygenic risk score for height, and we can see how much the polygenic risk score actually matches their actual height. And if these were 10 embryos, and we had selected just one, is this the tallest member of the family? Most of the time it wasn't. Now, there's a second version of polygenic embryo screening, which is for diseases. What is your risk of developing a particular disease? Like I say, type 2 diabetes or schizophrenia, I mentioned those, but it could be anything that you think of. Any common disease that's not like a genetic disease of birth, like Tay-Sachs, as I mentioned, or those kinds of diseases, is what we call a common complex disease. And at this point, we've looked at it, and the situation is a little bit more complex. Here, it really depends on many, many variables that haven't yet been well articulated by the couple of companies that are currently offering these services and that are not well understood by the public or even the scientific community. And this involves something called the selection strategy. How are you going to select when you have many different diseases to choose from? Let's say this embryo over here has a high risk score for diabetes, but a low risk score for major depression. And let's say another embryo over here has a high risk score for Alzheimer's, but an average risk score for everything else. How do you make that decision? Are you just going to exclude embryos that have very, very high risk scores? Are you going to look for one that has the lowest risk score? Are you going to try to combine across multiple diseases? These are all issues that we are currently studying right now. And that's really the essence of my research. So there's no clear answer as of yet. One other thing that we're really very interested in studying and in communicating, and that is very complex to communicate. Let's imagine that you can reduce the risk of a given disease by, let's say, even 40 or 50%. And we think it's possible that relative risk reductions may be more feasible than we really originally anticipated with polygenic embryo screening. The risk for schizophrenia, for example, in the general population is 1%. So if I tell you there's a relative risk reduction of 50%, you might say, that's great, that's a huge risk reduction. But if I tell you that there's an absolute risk reduction, meaning that the absolute chance of developing schizophrenia is reduced by 0.5%. So you go from a 99% chance of not developing schizophrenia to a 99.5% chance of not developing schizophrenia. Now that sounds very different. So we get into issues not only of statistical genetics, but also of scientific communication and understanding of risk. And that's the other piece of the research that we're currently doing, which is trying to understand if a doctor says something about risk, how does the patient hear that? What is the difference between what we think we're communicating in terms of risk reduction, which is a statistical concept, and what the patient hears in the clinic and how they make a clinical decision with their doctor. And the bottom line of all of that is we feel that a lot more research really needs to be done on both ends of the scale, both the statistical side and the communication side, in order to really understand how this could possibly be applied.
Yeah, no, definitely. There's so many kind of points that I want to touch upon for kind of
Sure.
what you've just said. I think the first thing, you obviously mentioned that there are companies that are kind of offering these services. In what kind of capacity are they offering those services, and how is this currently regulated as well?
Yeah, They're currently offering it privately, either direct to consumer or direct to doctor. It's really up, I think, up to whether the patient has heard of it or whether the doctor has heard of it. It's a brand new concept, so I think, in most cases, it's not something that people are going to run across. But if they do run across it, it's not regulated, or certainly in the United States, it's not at all regulated. Regulations really vary dramatically by country. And the whole landscape of how this would work is quite different in every country in the world. So in the United States, for example, there's absolutely no regulation, and there's also no government reimbursement. And so this is really something that a private individual might pay for if they can afford it. And that brings up, all sorts of issues of equity and social justice and so forth. But that's, of course, part of the larger healthcare debate. But in terms of other countries, for example, in the UK, the entire process of embryo screening in IVF is highly regulated. And so in the UK, there's a government commission which directly dictates not only which conditions can be tested, and only monogenic conditions can be tested, but it actually dictates which specific genetic variations are allowed to be tested. And they're sort of on a list or a menu that is specifically dictated by this government agency. And so my sense, and I'm not only am I not a lawyer, I'm certainly not a British lawyer. My sense is that that this would not be even allowed in Britain unless there was some sort of loophole, because it's not monogenic screening. Maybe that there would be some kind of loophole. And in other countries, those sort of represent the two ends of the spectrum of how this is regulated. In Germany, there are individual review boards that have to approve of individual screenings. It really varies greatly.
Yeah, because in my head, I think that obviously polygenic risk scores themselves are not refined very well. Like as you said at the start, like we can only predict like 5 to 10 kind of percent. So how are we able to then kind of apply this to embryos, if that makes sense?
Absolutely, and in the realm of clinical applications of polygenic risk scores in adults, there's currently a working group that just published a paper in Nature and just really called for a process in the same way that the governing bodies try to regulate or create at least standards of care for monogenic screening. There's a desire to create a process for standardization of how polygenic risk scores are even reported in the research literature. One thing that's very important that we haven't even touched on is that polygenic risk scores are only as good as the research base that they are drawn from. In order to develop a polygenic risk score, we have to understand all of these tiny genetic components across the genome and how they contribute to risk. And those are based on large-scale genome-wide association studies that get published in the literature. And they can vary in quality depending on the size, particularly of the cohort that is under study. So if you have a GWAS that looked at 10,000 patients, that's going to be maybe okay. But if you had a GWAS that had 100,000 patients, that's going to be much more accurate, or even 200,000 patients. But it's very critical to understand who are those patients, what is their exact diagnosis, and most importantly, what is their ethnicity and population ancestry. And in most cases, polygenic risk scores have been developed for individuals and in individuals of European ancestry. And that's a big issue that's been hotly discussed in the field. There needs to be much more genetic studies in other ancestries, and particularly ancestries that have been poorly studied in the literature so far, such as individuals of African ancestry. They are going to be largely left out of polygenic risk score clinical applications because they've been largely left out of genome-wide association studies up to this time. And there's massive efforts now to try to collect these samples for genome-wide association studies to try to play catch up here. But this really needs to be understood even for adult clinical applications of polygenic risk scores. So my urgent call to the field is that governing bodies, research societies, and so forth all get together and try to understand and develop standards for reporting before we can even get to identifying standards for utilization and application of polygenic risk scores in the clinic and in the IVF clinic in particular.
Yeah, because that was one of the things that I was thinking in my head as well. Like obviously, at the moment, polygenic risk scores are can't really be applied to other populations other than European because of the data. And I feel like you would hate for it to like things to progress, but we still don't have the data for it to kind of progress for everyone, if that makes sense.
Yes, right now that's the case. It's very unevenly distributed, and some would suggest unfairly so, and that would be a very big limitation for a lot of people who just certainly at this point would be ineligible because the data don't exist for them.
Yeah. What are kind of other conditions that are being explored in this context? Because as you mentioned, like schizophrenia is such a complex disease, and we still don't fully understand the kind of the genetics of it. So I'm just thinking how that then going to be applied in the embryo screening when we still don't kind of really understand it that well.
Yeah. Well, that, the schizophrenia I mentioned frequently because that's my original and primary area of research. But even diseases that are perhaps a little bit more well understood, like diabetes and so forth, the amount of genetic variation that we can explain is still quite limited. So even if we understand the physiology of disease, what we understand at the genetic level is not much greater. So again, a difference between utilizing polygenic risk scores in the adult clinic is that we can utilize all of the additional clinical information that we have and that we understand. So if somebody wants to understand, let's say there's a 50-year-old male who is non-smoker, but overweight, has cholesterol numbers of X, Y, and Z, and so forth. And we want to understand his potential risk for a heart attack in the next 10 years. We might have a risk we can certainly imagine at least a risk calculator that includes smoking status, the cholesterol numbers, all of those things, and in addition throws in a polygenic risk score to help refine and increase the accuracy of a risk calculator. That's something that's currently being studied today, and where we can use what we already know medically and biologically about heart disease to throw into the risk calculator. When we're dealing with an embryo, we have no other clinical information to go on. We don't know if that embryo is a smoker. I hope he's not smoking yet. So all we would have is the risk score. All we would have is the genetics. So that again limits us to just know, to just the bare essentials of what we can learn from genome-wide association studies. And even within the realm of genetics, that's leaving out things like rare variation or ultra-rare variation, which is something I also study in the separate part of my research. Currently, what we capture in polygenic risk scores is common variation, which is variation that is spread throughout the general population at a frequency of genetic variants that are in 1% or 5% or more of the general population, whereas a lot of the action in terms of disease risk happens at the realm of very rare or even private genetic variation that occurs de novo when the embryo is formed, and that will never be incorporated into a polygenic risk score.
Yeah, kind of another aspect of it as well is with like monogenic disorders, I still feel like we're not amazing obviously at diagnosing that either, because obviously some people go into like their 30s, 40s or whatever, and they still don't have a diagnosis, and they have kind of like a rare like monogenic disorder.
Right.
So I feel like sometimes like should we potentially not focus on that where we kind of know kind of more information?
Right. Well, that's yes, and so that's sort of like the UK model that I was mentioning before, that it's sort of like looking for your keys where where the light is under the lamppost. There are certain things that are well understood about monogenic disorders, and those can be clearly specified. But it is true that there is still a large amount that is unknown about monogenic disorders, and that there are many patients, you're right, that have a very complex clinical picture, and they still can't figure out, though, what the underlying genetics are. So it is certainly not the case that monogenic disorders are simple, but what we can say is that certain components of certain monogenic conditions are currently well enough understood that they are actionable. So I think there we would get into the issue of clinical actionability. And I think that's sort of where the rubber meets the road in the clinic, is that, what can science tell the clinician and tell the patient with what degree of certainty, with a high enough degree of certainty that it is clinically actionable. And so, like in the UK, they take a cautious or conservative approach, that where we have a high degree of certainty, we consider that to be clinically actionable. And in the US, that's sort of turned on its head. Whatever you can do and whatever you can get away with in the clinic, that's the action that you take. And it's sort of a libertarian approach of, caveat emptor.
Yeah, I mean, say if tomorrow we perfect this technology and it's really accurate. Kind of, when do we start to have the discussions about kind of where do we draw the line? Because obviously we're talking about kind of about mental health and things like that. When do we draw the line on what diseases we incorporate into this embryo screening? When should we start having those conversations? Because I feel like polygenic embryo screening for me has come out of nowhere. I hadn't even heard of this. So
yeah, I think I'm sorry to interrupt, but yeah, I think the reason I interrupted is that we need to have those conversations yesterday. I mean, that's when we need to have those conversations. I mean, absolutely, there are so many implications at the social level, at the ethical level. The word eugenics gets thrown around, and that word sometimes can be shed more heat than light. And it's, even if you take away that word and you don't you don't worry about it being utilized by government to do wicked things. There still could be potentially wicked implications in society. If we screen out certain conditions, then that adds a stigma potentially to individuals who are still carrying those conditions. This is something that is already being discussed in the disability community with respect to monogenic disorders, as well as chromosomal abnormalities such as Down syndrome. This has been discussed. In many countries, 90 to 95% of families that receive a prenatal diagnosis of Down syndrome choose to terminate the pregnancy. And the Down syndrome community has discussed what the implications are for those who are born with Down syndrome and what that means in terms of stigma. And in this field, the movie Gattaca is often talked about. And I think, even though it's a science fiction movie and there's a lot that is fanciful about that movie, the idea of someone who is born with conditions that some might perceive to be preventable brings about a potential for stigma or shame that absolutely needs to be addressed at the level of societal and ethical discussions. Yeah. And needs to be addressed today. I mean, you see it in COVID. People sometimes say, well, I tested positive for COVID. Oh, well, what did you do? Is there a stigma on the person who tested positive for COVID? Was it their fault somehow? So absolutely, this raises the questions that you're posing, Shannon.
Yeah, because I feel like mental health is already such a taboo subject, and I feel like over the years, it has gotten a little bit better. People feel that they can come out and discuss it more. And you would hate for them to say we rolled this out and then it was screening to not have schizophrenia or not to have kind of depression, and then it
Yeah.
create a further kind of divide, and people then don't kind of want to speak out.
I'm really glad that you mentioned that in particular, because mental disorders and psychiatric diagnoses often are more stigmatizing than other forms of medical illness. 50 years ago, the word cancer was unspeakable, and people called it the C word and so forth, and that stigma has slowly eroded over time. But in mental illness, there's still a very large societal stigma around those, and I agree. And I think I would be remiss if I failed to mention the fact that the concept of eugenics not only arose in the context of mental illness and in the context of intelligence and trying to breed out of the population individuals with who were at the time, 100 years ago, referred to as mentally defective. And that not only did eugenics emerge out of the fields of mental illness and mental issues, but the entire field of genetics itself actually emerged in some ways out of this. Certainly the field of statistical genetics. All of the founding fathers of statistical genetics were actually eugenicists who were attempting to breed out mental illness and low intelligence out of the population 100 years ago or more. And this is something that really needs to be grappled with and reckoned with by our field and any of us who consider ourselves geneticists. This is not incidental to the history of genetics or a misapplication of genetics, but it is part of the origin story of the field of genetics. And in order to avoid those horrible, horrific implications, we need to address those head on. And again, in conversations that should have started yesterday, before we proceed any further in understanding how to apply these.
Yeah, because obviously, as we mentioned, like there are commercial companies who are already doing this, and I feel like the conversations are like not really happened. So you'd hate for it to like get any further, and we don't have these like important conversations. How do you think we can ensure that there is transparency and kind of engage the kind of population in these discussions and start kind of bringing it to the table?
Well, thank you for asking that. The burden is really on us as a scientific community. I'm struck by the fact that CRISPR, the clinical and ethical implications of CRISPR genomic editing, which are far more complicated to implement in the clinic, have been much more broadly discussed in the scientific community and in the general population and by the political regulators and so forth. When the so-called CRISPR babies were born a few years ago in China, that was earth-shattering, literally almost earth-shattering news. It sort of stopped the world, scientifically speaking, and urgent sets of regulatory decisions were made. We feel that that it's up to the scientific community to do better with respect to polygenic embryo screening. In one of our recent papers, we just did a quick literature search in PubMed, and we saw that hundreds of papers had already been published on CRISPR embryo editing, and literally fewer than a dozen papers on polygenic embryo screening have been published. And if you screen the PubMed search even further, where you force the word ethics into the search, you still get 100 or more hits in the CRISPR literature, and you get literally one hit in the polygenic embryo screening literature, and that was our own paper. Now that's gotten a little bit better. There's a few hits now since we published that, but literally it's an order, 2 orders of magnitude difference, and that's on us as scientists to do better and to raise the awareness in the general public. And that's why I thank you so much for hosting me here and getting an opportunity to address your audience today.
Yeah, no, because I definitely feel like it kind of has flown under the radar. But even when I found out about it, which is only recently, I then kind of was having like these ethical discussions within my own household, and just kind of, because I didn't really know about it, and then now like I know about it, I'm kind of thinking differently and doing a bit of research and having like those discussions as well. So I think just kind of getting out there is so important, just to kind of kickstart these conversations.
Yes, and the more that I learn about it, and I think about this every day now, my thoughts and my understanding of the ethical implications have evolved tremendously as well, and are still evolving. So, there, I think, are very easy knee-jerk reactions that one might have on either side of the discussion. And I think that it just takes discussion to really get at the nuances and the subtleties, and it takes scientific research to provide data to really inform those conversations. So that's why we were glad to recently be funded by the National Institutes of Health and specifically the National Human Genome Research Institute in the U.S. To do more research to be able to inform those discussions.
Yeah. I mean, if we kind of look at it on a global aspect, recently I've been kind of writing pieces about how genomics is being like applied in different countries and kind of the capabilities around the world. If this kind of gets rolled out, what kind of impact do you think this will have on kind of the disparities that already exist? Because in many countries, I think they screen for like 3 or 4 conditions, and then I compare that kind of the UK and the US, and we screen like so much more, and I just feel like it might kind of have a knock-on effect on the already existing disparities.
Yeah, it certainly would. I mean, the phenomenon of the rich getting richer would certainly apply here. This process would not be cheap. So I think how much of a benefit somebody would derive from that is still up for debate or for research. It's possible that someone might be paying a lot for a very modest amount of return, but there's no question that because it would be expensive, it would feed into of that. It also raises a whole issue of who is seeking IVF. A lot of people who seek IVF now are individuals with fertility issues, where even getting one healthy and implantable embryo is hard to do. And if a baby is born, then issues of like what their polygenic risk score is secondary or not even on the table. But if this raises a whole new set of people who seek IVF specifically in order to obtain these scores, that really changes the game. And so that's something that we need to understand as well, is not only how would it change for current patients, but for future patients who aren't even currently considered patients, if you get what I'm saying.
Yeah, I think that's going to raise like a whole other set of ethical questions, because obviously IVF is really, really expensive. So then it kind of will go down that kind of route of like, I don't want to say it, but like designer babies and things like that. And obviously the rich being able to do it and other people not being able to as well.
Because at the technical level, it's not cheap, but it's not prohibitively expensive to do this if you've already started the process of IVF. If you're seeking to start the process of IVF just in order to do this, then that raises a whole other set of issues.
Yeah.
And then and it also raises potential risks that are also not well understood. What are the risks of IVF to someone who is otherwise healthy and who otherwise might conceive without IVF? It's still not well known, what are potential health risks of doing IVF, taking embryos, pulling cells out for genetic testing, and then implanting the embryo again and delivering that baby, compared to just the natural process of conception and birth. Could there be hidden risks either to the mother or to the baby in just undergoing that set of procedures, even if you can afford it? So that needs to be weighed in the whole cost-benefit analysis as well.
Yeah. We also kind of don't know what impact it will have on evolution, but I feel like that's kind of a whole other discussion. What do you think that the future of this kind of area will look like?
Well, one concern that I have, if you want to get into the issue that you raised of evolution, I think evolution itself is a little far down the road, but if different societies or different nations don't agree on how this should be utilized, or if there were perceived to be sort of a genomic arms race across nations, that might sound a little fanciful or a little far-fetched, but that would probably be a source of considerable concern. But in the short run, I think that my interest is, as a scientist, just getting as much understanding and information as possible, and understanding how to communicate that to doctors and to patients. I think the biggest risk, I think we see this again with COVID. Developing scientific knowledge is hard. Communicating it is even harder. And that's why companies such as yours are so important. And you know, here we are 18 months into the pandemic. And I think if you took 10 people on the street and asked them to just explain how COVID works, in general terms, in layman's terms, I'm not talking about getting into a deep molecular understanding of it, but even just in layman's terms, how do you catch COVID? I don't know how many out of 10 would be able to explain it to you in ways that make sense. And that's our failing, and we have to do better.
Yeah, no, definitely. Communication is just so important. Thank you so much for joining me today, Todd. It's been really interesting, and I could talk to you for the rest of the day about this, but I think this just kind of highlights not only how far we've come in genomics in terms of progression and advancements, but also how important, as we said, it is to communicate with people and just kind of get the kind of discussions going. So thank you so much for joining me.
Thank you so much for hosting me. I've greatly enjoyed the conversation.
Thank you.
Hello everyone, if you enjoyed this video, then make sure you check out some of our other videos in our series by subscribing below or going to our website, frontlinegenomics.com. I hope you enjoy.